Salam sejahtera, nama saya MATHIAS dan anak saging, dan nombor matrik saya adalah 2023858554. So, saya akan bincangkan tentang task 1, iaitu from the given link, fill up table 1 with related values assuming 1 month equivalent to 30 days only and age equal 2 months. And the values are based on the real data indicated by its closing value in MYR. So, untuk dapatkan data ni, kita menggunakan link yang diberi. Untuk dapatkan line merah dan juga line biru, kita tekan indikator exponential moving average 50 untuk dapatkan blue line. Dan untuk dapatkan red line ialah tekan simple moving average 50. So, macam mana saya dapat nilai 9.18? Contoh nilai 9.18 ini, kita cari dekat 30 March 2023. So, kita cari 30 March 2023. So, untuk line green line, kita dapat closing dia 9.18. Kalau red line 9.52, blue line ialah 9.43. Macam ni. So, dapat nilai dia. So, cari semua tarikh ni untuk dapatkan semua nilai ni. Untuk next step for question B, so dia nak cari Lagrange interpolating polynomial for the given values in table 1 in A for all three lines, green, red and blue. So, untuk June 30, 2024, untuk dapatkan nilai atas ni, kita menggunakan X tolak X2 dalam kurungan, lepas tu darab X tolak X4 dalam kurungan, dan seterusnya sampailah ke X sampai ke X26. So, kita dapat nilai atas ni. Untuk nilai yang bawah ni pula, kita bahagikan. Kita menggunakan formula dia dalam kurungan X tolak X0 tolak X2 darab dengan X0 tolak dengan X4 sampailah ke X26. So, kita akan dapatkan nilai yang bawah ni. Nilai atas ni dan nilai bawah ni kita akan bahagikan dan darab dengan nilai data yang kita dapat daripada graf tadi, graf TNB. So, kita cari untuk 511 days untuk green line, blue line dengan red line. Seterusnya kita cari untuk 811 days juga. So, untuk 811 days juga formula dia sama. Sampailah kita cari kan dari line 1, line 3, line 4, line 6, line 7, line 8, line 9, line 10, line 11, line 12, dan last kali ialah line 13. So, kita dapat semua nilai green line, blue line dengan red line untuk 511 days dengan 811 days. Lepas tu kita totalkan June 30, 2024 511 days dengan juga April 30, 2025 811 days. Kita totalkan semua data yang kita dapat daripada green line dan kita dapat nilai dia 13.85 12.352. Untuk blue line pula 12.91668. Red line 12.83600. Untuk 811 days, green line dia negatif 242.89341. Blue line pula 143.33794. Dan last kali red line 290.16996. Untuk soalan C, dia nak calculate the absolute error and percentage absolute error for task 1B. So conclusion dia, kita nak cari comparison untuk for B1 and B2. Absolute error untuk green line 511 days, kita dapat 4.648%. Blue line 10.322%. Untuk red line 4.4%. Untuk green line 811 days, kita dapat 25.66 times 10 power of 3%. Blue line pula 129.77794 kali dengan 100, kita dapat 12.98 times 10 power of 3%. Red line pula kita dapat 27.66 times 10 power of 3%. So comparison dia, the interpolating polynomial was most accurate for the green line and actual data, followed by red line with blue line having the least accuracy for this date. Untuk for B2, accuracy decreased slightly for all three threads due to the extrapolation over a longer time interval. However, the green line remained the most accurate, followed by the red line. Jadi the blue line ni proved to be the least reliable for future estimation. Untuk blue line dia dapat kurang daripada red dengan juga green untuk future estimationnya. So that's all from me for task 1. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is AFIFA binti Yusri, and today I would like to present my presentation of the assignment, which is task 2. So for the first page is we are required to construct the Newton finite divided difference, the NDD table using the actual TNB closing price data from the table 1. The X value were based on the consistent 30 days interval for each month, making the data equally spaced in terms of days. By using the Excel, we systematically calculated the divided differences starting from the first order up to the fifth order. Each order was calculated by the formula, which is fxi xi plus 1 equal to fxi plus 1 minus fxi over xi plus 1 minus xi. The highest order differences followed similarly, building open the value from the previous steps. This table serves a key structure in interpolation, enabling us to generate the polynomial that estimate value in between known data points. Next, for the question 2, after constructing the NDD table, we use it to form the Newton's forward divided difference polynomial, which is most accurate when estimating value near the beginning of the data range. So we substitute the known X value and the divided differences into this formula, simplifying it to a complete polynomial equation. The forward polynomial allows us to estimate stock price around the earlier dates, particularly near x0. Next, for the third page, which is we derive the Newton's backward difference polynomial, which is ideally for predicting the value near the end of the data set. This polynomial begins from the last known point x11 and work backward. The last value of x. The formula is similar in the structure to the forward polynomial, but the terms are arranged to reflect backward differences. Like before, we insert the divided difference value into the formula to get the complete polynomial. This equation is useful for approximating values such as those in the earlier 2025, where the x value is closer to the latest data point. And the last question is, we apply the least square method to fit an exponential model of the form of y equal to a exponent power of bx. To make the equation linear and suitable for the regression, we transform it in it's using natural logarithm, which is ln y equal to ln a plus bx. This linear equation allows us to apply least square formula to calculate ln b and ln a and b using all the available data input. We use the following equation as shown in the in the solution. Then after solving, we exponentiate ln a to find a. This model provided a smooth curve that captured the overall trend of TNB stock price, especially useful for the forecasting future value beyond the available data. So that's all from me. Thank you.
That's true. First, we identify the observed equation. To the observed equation, we just like this. And we need to determine the gender polynomials of the grade. And the formula for this, which is the gender polynomial of the P2, is just like in point. After that, we substitute the fixed value of function of every P in equation 1. And the fixed value of every P is just like in 2, 3, and 4. After we substitute 2, 3, and 4 into 1, we can get the general equation just like what's the question 1. Then next we move to the next question. The question is identify a suitable linear transformation if necessary. So first, we need to transform x to T linear since our data is like 1 and 2. Then let x to be to a t plus b and we label as 3. After that, we solve them to get the value of a and b. So that we know the value of a and b is 1 and 2. So we substitute value A and B into the equation 3 to get the new value of x. After that, we should be rewrite yx in terms of yt to answer this question. And as a conclusion, the transformation was required since xe in interval 0 and 2. Now, let's move to the third question. For the question A, this is no transformation is required since the interval is -1 and 1. Even yx equal to the in 1, and the formula Legendre polynomial degree 2 is as described in 2. We need should solve that by using the value equal to 1. After that, we find the coefficient of n1, a1, and a3. And after we get to every value of n0, a1, and a3, we substitute into the formulas 7 to get the final answer. And the final answer just like this. And the last question, this is need a suitability transformation since our interval is in 2 data, and the linear transformation of x to t just like in 3. Then we apply the formula in 4 and solve them to get the value of a and b. And after that, we rewrite the yx in terms of yt. Then we determine the coefficient of n0, a1, and a2 by using the formula in 5 to get the every value of a. After we get the every value of a, substitute them in to equation 9 to get the value of equation in 10. After solve all of them, should substitute the equation in 11 in the equation 10 to get the final answer. So the final answer for this question is just like this. That's all.